Hello, boys and girls. Welcome to another edition of Think Different Television. Yeah, we are going to now do trigonometry, and in particular the trigonometric ratios we're talking about here. SOHCAHTOA. All right, here is our lesson for today. So copy this stuff down. You already know Pythagoras' theorem or Pythagorean theorem. A squared plus b squared equals c squared, or the hypotenuse squared, same thing. And we have SOHCAHTOA. So let's do it. Here you go. Boop. So trigonometry, first thing, has to do with right triangles. So if you don't have a right triangle, as of now, you cannot use these trigonometric ratios we're about to talk to. So right triangles are very important. Only right triangles only. Okay. So the first thing we have to do is label stuff. So the first thing you're going to do is you notice the hypotenuse is always opposite the right angles. This is the hypotenuse. Now, it depends on which of these acute angles you're talking about. So let's talk about this one right here. This is theta. This is a Greek letter. This means like some unknown angle measure. This could mean like 30 degrees, 31 degrees, 45 degrees, 51 degrees. You don't know. So this is like saying x for an angle is this theta. You call it theta. You want to spell it? Theta. Theta. That's how you spell it. So if I'm looking at theta, this angle right here, I draw a straight line across, and this is called the opposite side. And then the side that's touching and it's not the hypotenuse, this is called the adjacent side. So you have three sides of every right triangle depending on what your reference angle is. So let's say that theta was up here instead. Let's say we're talking about this angle and not this angle. Let's say we're talking about this one. Do things change? Well, let's see. So the hypotenuse doesn't change. It's always opposite the right angle. Label that. Remember I said the opposite, you draw a line across? Yeah, so now the opposite is down here. If I'm looking at this reference angle, this theta, then this side opposite it is called the opposite. And the part that's touching it, that's not the hypotenuse, the other ray or line is the adjacent. There you go. So that's very important that you're able to label. Now, what are we labeling? We're labeling the trigonometric ratio. So we need to know all these parts so we can know the sine, cosine, and tangent. That's not the sin, that's called sine, cosine, and tangent. That's how you pronounce those. So, sine of theta, SOHCAHTOA. So this tells you what's up with sine. Opposite divided by or over, you could say, but it means divided by hypotenuse. Hypotenuse. There you go. Cosine is adjacent over hypotenuse. This is something you have to write down. You're going to refer to it a lot as we move forward. And then tangent is opposite over adjacent. And there we go, SOHCAHTOA. So SOHCAHTOA is easy to say, it's easy to remember, so it helps you remember this very, very quickly, just saying SOHCAHTOA. Now, here is an example. What we're going to go over. Copy this down, pause the video. All right, cool. So you have a 3, 4, 5 right triangle, and see this letter here? This is going to tell you what angle to look at. It doesn't have theta, it just talks about the angle. So angle X is what I'm looking at first with 1, 2, and 3. So I'm going to label my triangle first, my right triangle. So opposite the 90 is opposite. A little abbreviation. Straight across is going to, no, sorry, not opposite. What am I doing? Hypotenuse, my bad. And then opposite here, opposite X, the 3 is the opposite side. And then touching angle X, that's not the hypotenuse, is the adjacent. So that's going to help me now. Now I'm going to look here. So sine of X. So sine of X. Sine is the opposite over hypotenuse. So now I'm looking at my picture. The opposite is 3. Hypotenuse is 5. Opposite over hypotenuse. Opposite over hypotenuse. So that's 3/5. So the sine of X is 3/5. Cosine of x. Cosine is adjacent over hypotenuse. So look at my picture. Adjacent is 4. Hypotenuse is 5. 4 over 5. Adjacent over hypotenuse. So this is 4/5. Got it. Okay, tangent. Tangent is opposite over adjacent. Opposite over adjacent. So that's going to be 3/4. You have to put it in this order. If you put 4/3, it's wrong. You have to put it in that order. Okay, so now let's talk about 4, 5, and 6. Now we're not looking at x anymore. We're looking at y. So that means that I have to, good thing to have a pencil. Pencil is good to have in math. My opposite and adjacent are going to change now because now I'm focused on y. The hypotenuse is still opposite the right angle, but now the 4 side is the opposite. And the 3 side is the adjacent. It's touching the angle, but it's not the hypotenuse, so that's the adjacent. So now my values are going to change a little bit if I'm looking at the other acute angle here. So let's see. Sine is opposite over hypotenuse. So opposite, if I'm looking at y now, is 4/5. So you get a different answer. Cosine of y, what's that going to be? Yeah, adjacent over hypotenuse, so that's 3/5. Bam. All right, tangent of y. Tangent of y is going to be opposite over adjacent. So I'll just go off my picture, 4/3. Yeah, done. Cool. Let's keep it going. All right, here you go. So what I did was I copied this down here. Oh, sorry. Oh, sorry, that's not working. Oh, let's do this. Just copy it down from here. No worries, hit the wrong button. No worries. So here's 1 to 6 on this picture, and here is 7 through 12 on this picture. All right, so here you go. So sine of A. So A is here. We have hypotenuse, draw a straight line, opposite, and then this one is adjacent. Go ahead and do 1, 2, 3 right now. Go. Ooh, I'm going to write sine of theta is opposite over hypotenuse. So cosine is adjacent over hypotenuse, and the tangent is the opposite over adjacent. There you go. So sine of A is 5/13. Yeah, cosine of A is 12/13. And tangent of A is opposite over adjacent, 5/12. 5 divided by 12. There you go. All right. How about sine B, cosine of B, and tangent B? Ready, set, go. All right, let's see what we got. So I know that if I'm looking at B, then the 12 side is the opposite, and the 5 side is now the adjacent. So I'm going to mark up my picture again. This is the adjacent side. So sine of B is 12/13. Cosine of B, adjacent over hypotenuse, is 5/13. Yeah. And then tangent is the opposite over adjacent. That's going to be 12/5. Cool. All right. Nice job. Let's keep it going. Last one. Here's a little bit more challenging. Copy this down if you don't have it. All right, cool. Let's do M. So I'm looking at M. Now it's sort of oriented a little bit differently, but don't worry. Look, there's the right angle. So this radical 5 is your hypotenuse. Oop, draw a straight line across, opposite. There you go. And then that would mean the 2 is the adjacent side. Go ahead and do sine M, cosine M, and tangent M. Go. All right, let's see what we got. Opposite over hypotenuse, 1/radical 5. Got it. And cosine of M is adjacent over hypotenuse, so that's 2/radical 5. Tangent of M is 1/2, 1/2. Cool. All right, now your job is to do the rest. Sine n, cosine n, and tangent n. Ready, set, go. All right, let's see if you did it. First thing, you got to make sure you got your triangle, right triangle labeled correctly. So this is the opposite side now, and this is the adjacent side if I'm looking at n as my reference angle. So now the sine is going to be opposite over hypotenuse, so that's 2 over radical 5. We're going to work on simplifying this soon, because this is actually not the full answer. That's okay, because you can't have a radical in the denominator. Cosine of n is 1 over radical 5. And tangent n is opposite over adjacent. That's 2 over 1, aka 2. Good work, everybody. Keep knocking these out. Keep practicing. These should be automatic.